So this is section 2.6. Again, we're going to let two functions, f of x, g of x, two functions. Then the addition of these two functions is going to be the first one plus the second one. Minus for these two functions is going to be the first one minus the second one. Multiplication is going to be the first one times the second one. Division is going to be the first one over the second one. The same thing. F composite with the g. That's mean, look, this function you have to visualize how it look like. F composite with the g. Imagine this is f. This is the f function. This is my hand, the f function, and this is g. So check, f is out, g is inside. That's mean f is going to cover g. F here, g here. You see, f is outside, g is inside. So f is going to cover g. Check, f is going to cover g. That means g is going to be inside and f outside. Now, g composite with the f. Now the opposite thing. Now here's g and here's f. Now g is going to be outside f, the opposite thing. So g is going to be outside and f is going to be inside. We're gonna do all these examples with numbers and functions. It's going to be easier to understand. I need to write down these. If you have any questions, let me know. So the first one, when they ask you, evaluate the function for f of x and g of x. So we have f of x equal x plus 3 and g of x. So here's the first one. I have f of x equal x plus 3 and g of x equal x squared minus 2. Now we need to find f plus g to the negative 1. F plus g to the negative 1, which is going to be, I'm just going to use the rule that says f to the negative 1 plus g to the negative 1. Then I'm going to plug in negative 1 here with the f function. So it's going to be negative 1 plus 3 plus with g function. So it's going to be negative 1 squared minus 2. Always be careful when you plug in negative 1 or negative number in the square root. Sorry, in the x squared, put parentheses, because the squared exponents for everything inside the parentheses, for the negative sign and for the number. So this one is going to be 2 plus negative 1 squared is going to be negative 1 times negative 1, which is equal to, sorry, equal 1. That's mean this one is going to be 1 minus 2. So in this case, this one is going to be 2 plus negative 1, which is equal 1. So the first solution is going to be 1. Next example, example 2, they ask you to find f minus g to the 8. Now the same, these two functions, but we're gonna find, so f of x is x plus 3, and g of x is x squared minus 2. Now they ask us to find f minus g to which number? To the 8. Be careful with the minus. Check what I'm doing with the minus. So let's go back to the rule. With the minus, always put parentheses on the second function. Always put parentheses on the second function so you can distribute the minus here. If not, you're going to do mistakes here. So put parentheses because you're going to distribute the negative sign. So f minus g to the 8 is going to be f to the 8 minus g to the 8. I'm talking about if you have x now, because you're going to plug in, but it's okay, put parentheses here. So this one is going to be f to the 8 I'm going to plug in 8 in the f function. So it's going to be 8 plus 3 minus, here's another parenthesis. I'm going to plug in 8 in g function. So it's going to be 8 squared minus 2. Let's keep going. So this one is going to be 11 minus 8 squared is 64 minus 2. That's mean this one is going to be 11 minus 64 minus 2 is going to be, I'm going to put 64. You see, you're going to distribute the negative sign. That means this one is going to be 11 minus 64, 62. So it's going to be negative 51. That's it for this question. Number 3, let's check number 3. Number 3, it says f times g to the 7. So I think the same two functions, x squared, yes, you see f of x and g of x. So now we need to find, here's f of x, g of x, we need to find f times g to 7, which is going to be f to the 7 times g to the 7. Now this means going to be equal, plug in 7 here in the f function. So it's going to be 7 plus 3 times, plug in 7 in g function. So it's going to be 7 squared minus 2. Now we need to simplify these two parentheses. So this is 10 times, this is 7 squared is 49 minus 2. That's mean 49 minus 2 is going to be 47. And 47 times 10 is going to be 470. So here is the 10. And this is 47. So the result is going to be 470. Let's check these 3 examples. The first one, write down the steps because maybe I'm going to ask you to show me the steps, not just the answer. So this is 1. This one is negative 51. And this one is 470. 470. I think we can check. I have to check it each one, like one at a time. Yeah. So this is one. I have to check it. The second one is negative 51. So take your time when you're working on these examples. If you have any questions, you can ask before we move into example 4. We're going to do the same thing, but now the same two functions, we do division. So 4, we have the same function, f of x is x plus 3, and g of x is x squared minus 2. Now we need to find f divided by g to the, which number? Number 4. Which is equal f to the 4 divided by g to the 4. That's mean you're going to plug in. You're going to plug in 4 in the f function. So it's going to be 4 plus 3 divided by, plug in g here. So it's going to be 4 squared minus 2. That's mean this one is going to be 7 over 4 squared is 16 minus 2. This one is going to be 7 over 16 minus 2 is going to be 14. You have to check. Can you simplify this one? Yes. Divide this one by 7. Divide this one by 7. So it's going to be 1 over 2. So always check with the division if you can simplify. That's it for this example. If you check example 5, let's check first. Here's 1 divided by 2. For example 5, let's check how we're going to solve example 5. Because example 5 is different. Because if you check the previous examples, they ask you to find for x. X equal number 7, x equal 4, x equal -1, x equal 8. But now in examples, which one? Example 5, they ask you to find in general, in x. That means your result is supposed to be a function, a new function with x. With the x, there's no number in it. The result is not going to be a number. For example, here's 5. We have two functions, x plus 7 and x minus 7. So let's check. Sometimes it's going to be a number. Sometimes, like some examples, the result is going to be just a number, like for this one. So A, we need to find f plus g to the x is going to be. I'm just going to use the rule. The rule says f plus g to the x is going to be f to the x plus g to the x. That's me. I'm going to plug in f of x, which is x plus 7 plus plug in g of x, which is x minus 7. Now distribute the sign so you can combine the lactants, because this function add to this function. So it's going to be x plus 7 plus x minus 7. 7 minus 7 going to be 0. That means the result for the first one is 2x, because x plus x is 2x, not x squared. Be careful. When you add in the variables, you're going to add the coefficient, not the exponents. For the second one, for B, they ask you to find f minus g to the x. F minus g to the x, which is going to be f to the x minus g to the x, which is going to be f to the x, which is x plus 7 minus g over x, x minus 7 is going to be equal. Here is the first function. Now I'm going to distribute the negative sign. If you're not going to distribute the negative sign, everything is going to be wrong. So negative times x is going to be negative x. Negative times negative is 7. Now x minus x is going to be 0. 7 plus 7, the result is 14. You see, for this one, the result is 14. See, now we need to find the multiplication. F times g to the x, which is equal f to the x times g over the x, then f of the x, which is x plus 7 times x minus 7. Now we're going to distribute. X times x is going to be x squared. X times 7, so minus 7x. 7 times x is going to be plus 7x. 7 times 7 is going to be minus 49. Cancel these two, so the result is going to be x squared minus 49. So this is the result for C. The last one, D, they ask you to find the division. F divided by G to the X is going to be F to the X divided by g of x, which is going to be f of x is x plus 7, g of x is x minus 7. That's it. You can simplify it. Do not cancel the x with the x, 7 with the 7. You can't cancel x on the 7s. That's it. This is the result. You can keep it like this. So let's check here. The first one is 2x. The second one is 14. The third one is x squared. Here is the squared. Minus 4, 9. And the last one is going to be here's, and we're going to say x plus 7 over x minus 7. What is the domain of this function? The domain. We need to find the domain for d. So the domain is, this is a rational function. The domain, that means which number I can plug in here to make the denominator undefined. So to find the domain, remember we check the bottom part and equal to the 0. Solve this one, you're gonna add 7. That means x is going to be equal 7. That's mean I can choose all numbers except 7. I can choose all numbers here except 7, because when you plug in 7 here, 7 minus 7 is going to be 0. Any number divided by 7 is undefined. That means the function is undefined at this number. So I can say my domain from negative infinity to 7. You see the 7, there's parentheses here. That means the 7 is not include the interval. The interval reach to number 7 and stop. If you put a bracket, that means the number is include the interval. Union start again from 7 to infinity. So that's the domain for this function. We can check that. 2 parentheses, negative symbols. Yes, here is the infinity, comma to number 7. And the union, I think we can see relation. No, symbol is with the set. Here's the union. With the set is going to be the union. And another parentheses, start again from 7, comma to infinity. Check this one. And you have like 2 or 3 examples, you're gonna do exactly the same thing. So it's good thing to practice, because example 6, example 7, the same thing, example 8, the same thing, example 9 is different. So let's solve one more example. Let's solve example 7. I'm not gonna do 6, I'm gonna do example 7, because it's gonna be the same steps. Oh, let's do example 8. Yes, let's do example 8. Because there's a root here. So let's do example 7. Now f of x equal 9x plus 1. And g of x equal x squared minus 9. Yes. Now let's do this example. The first thing A, they ask you to find f plus g to the x. So f plus g to the x is going to be f of x plus g of x. Now we're gonna plug in. So f of x is 9x plus 1 plus g of x, which is x squared minus 9. It's addition between 2 functions. So 9x plus 1 plus x squared minus 9. Let's combine the like terms and write down from the highest exponent to the lowest one. So it's going to be x squared, 9x plus 9x, 1 plus minus 9 is going to be minus 8. That's it. This is the result. You don't have to move forward. This is the result, the addition of these two functions. The second one be f minus g to the x, which is equal f of x minus g of x. So it's going to be f of x is 9x plus 1 minus g of x, which is x squared minus 2. So it's going to be 9x plus 1, distribute the negative sign. So it's going to be minus x squared plus 9. Now check the result is going to be different. It's going to be negative x squared plus 9x. 1 plus 9 is going to be 10, plus 10. So this is the second one. C, we're going to find the multiplication. So f to the x, f times g to the x. F of the x times g of the x. So it's going to be f of the x, which is 9x plus 1, times g of the x, which is x squared minus 9. Now in this one, you have to distribute. So 9x times x squared is going to be 9x cubed. 9x times 9 is going to be negative 81x. 1 times x is going to be plus x. 1 times 9 is going to be minus 9. Now it's going to be 9x cubed, negative 81 plus x, negative 80x, and we're just going to combine these together, minus 9. That's it. This is the result for this one. D, this says the division. F divided by g to the x is going to be f to the x divided by g to the x, which is going to be f of x. That's mean 9x plus 1 divided by g of x, which is x squared minus 9. That's it. You can simplify it. You can factor this one. It's going to be the same thing. You can simplify this part with the top part. So that's it. This is the solution for D. Again, they ask you to find the domain for D. The domain for the D, we're going to take it's a rational. So we're going to take x squared minus 9 is going to be equal 0. Then solve this one. You can say x squared equal 9. Take the square root for both sides. So x is going to be plus or minus 3. That means I can choose all numbers except 3 and negative 3. So how are we going to write down the domain? The domain you can write down from negative infinity to negative 3. Union. That means I can choose then all the numbers between negative infinity and negative 3 except negative 3. Union from negative 3 to 3. And another union from 3 to infinity. That's the domain for the last one. Let's check these answers. So the first one, the addition, the result is going to be x squared plus 9x plus minus 9 minus 8. And the second one is negative x squared plus 9x and plus 10. And the next one is 9x cubed. So 9x to the power 3 and minus 80x minus 9. Next one is going to be division 9x plus 1. Why like this? 9x plus 1 over x squared minus 9. And the domain is going to be from negative infinity, comma, negative 3. The first one, union with the sets. Here is the union. Another two parentheses from negative 3, comma, to 3. And another union, another two parentheses from 3 to infinity. That's it for this question. So with C, the wrong thing we did here, because 1 times x squared is going to be x squared. That's mean this one is going to be the solution. Perfect. So plus x squared minus 9. You can write down like 9x cubed plus x squared minus 80x minus 9, or you can keep it like this. Both is going to be right. So I'm just going to add here plus x squared. Do they ask us to? No, they'll ask us to write down from the highest to the lowest. So that means we can write down like this.
It would be 81x.
Yeah, yeah, you have to keep this one. Let's go to the next example. I'm gonna do this example because there's a root here. Because sometimes when you get roots, you're gonna say, how I'm gonna add these. This is the easiest one because you can't combine this part with the root. So for example, 8 or 8, now we have f of x equal x squared plus 5 and g of x equal square root of 2 minus x. So now the first one, f plus g to the x is going to be f to the x plus g to the x, which is going to be f of x, x squared plus 5, plus g of x, which is 2 minus x. You can't combine these, so that means this is going to be your solution. The same thing with the b. If you say f minus g to the x is going to be f to the x minus g to the x, which is mean f of x, which is x squared plus 5, minus g of x, which is 2 minus x. That's it. You can't simplify and check the difference, just the sign. The same thing with multiplication. F times g to the x is going to be x squared plus 5 times g of x, which is 2 minus x. You can simplify this one, so you can just type it like this, or you can type it like this. You can say 2 minus x, parentheses, x squared plus 5. And I think if you type it like this, also is going to be right. So one of these is going to be the solution. df divided by g to the x is going to be f of x divided by g of x, which is going to be f of x is x squared plus 5 divided by square root of 2 minus x. The same thing with this one, you can simplify it, so just keep it like this. Now, what about the domain? That's important part. The record for this one. Over the square root of x, 2 minus x. 2 minus x. And again, for the domain, take everything under the root greater than 0. We can't include the negative side, the equal sign. Why? Because if I say equal 2, that means when you plug in 2 here, 2 minus 2 is going to be 0. Anything divided by 0 is going to be undefined. That's why I'm not going to include the 2. Solve the inequality. And here, when you divide by -1 or negative number, you're going to switch the sign. So x less than 2. This is 2, not -2. That's mean less than 2 from 2, and all the number less than -2 goes to the negative infinity. But when you write down the interval, you're going to start from the left to the right. So from negative infinity to 2. So both is going to be parentheses. That means the domain here is going to be 2 parentheses. And from negative infinity, comma, to 2. And that's it. The third one should be right. If not, just cancel the parentheses. Yeah, it's right. If you write down this without parentheses, it's going to be okay. That's it. Example 9 and 10. But 10 is the composite function. Example 9, we need to find f minus g to number 2. But we have 2 graphs. I think I can. Maybe it's bigger. No, this is the biggest one. So for example 9, we need to find, we have a graph for f and a graph for g. So we need to find f minus g to number 2. That means the x value is 2. So the function says f to the 2 minus g to the 2. Now I'm going to look for f function when x equal to how much the y value. Because f to the 2, that's mean the y value. So here is the f function, this one. When x equal to, here is 1, 2. How much the y value? The graph is not going up and down. Stay here. That means the y value is 0. So f of 2 is going to be, the y value is 0 when x equal to, minus, parentheses, g of 2. So here's the g function. Here's 1, 2. I'm going to go to the y value. That's mean up, up, up to the graph. That's mean the y value at this point when x equal to is 2. So we're going to write down 2 here. 0 minus 2, the result is going to be -2. The second one, they ask you to find f times g to the 1. That means x equal 1, which is equal f to the 1 times g to the 1. Now f to the 1, let's go to the f function. When x equal 1, y equal 2. Must mean this one is 2 times g of 1. When x equal 1, g, the y is 3. At this point, the y is 3. So that means 2 times 3, and the result equals 6. That's it. This is for example 9. So we're going to type here -2, and you're going to type here 6. That's it for example 9. For example 10, we're going to do the same thing, but now we have the composite function. And then let's do 2 more examples about using the composite function before we move into the last examples. Now we have f composite with g to number 2. So example 10. Now we have f composite with the g to number 2. Yes, to number 2. So it's going to be f is out, g to number 2 inside. F is out, g of 2 is inside. That's mean f and g, f is going to be cover g. So I'm going to write down this. Look, well, here's the f. Let's work on the g function. With the g function, when x equal 2, how much the y on the g function? When x equal 2, here's the g function. When x equal 2, y equal 2. So that's mean everything here is going to be 2. Now I'm going to use the f function. F to the 2. I'm going to go to the f. When x equal 2, how much the y? The y is 0. So this one is going to be equal 0. The same thing if you're doing g, circle f. I think the same number, yes. To the 2. Now we have g is out and f to the 2 inside. Here is the g, open parentheses. F to the 2, that's mean this is the x. How much the y value with the f function when x equal 2? When x equal 2, the y value is 0. So I'm going to put 0 here. Now, when x is 0, how much the y value with g function? So let's go to the g function. When x is 0, how much the y? Here's x equals 0. How much the y with the g function? The y is 4. So I'm going to, this one is going to be 4. That means the first one is 0 and the second one is 4. Submit the solution. That's it for example 10. Any questions so far? So the first one, I'm going to find f composite with the g for x. F composite with the g to the x is going to be f is out, g of x inside. This is the rule. Now here is the f out. Now g of x is not a number, it's in general. So what I'm going to do, I'm going to write down the whole g function, which is x plus 3. Careful here. I'm going to write down the whole g function here. Now, f to x plus 3. That's mean instead of each x in f function, you're going to put x plus 3. Again, instead of each x in f function, you're going to put x plus 3. Because here it says f to the x, we have only one x. F to the x, we have just the x. What about if I have f to x plus 3? So it's going to be, you're going to plug in x plus 3 instead of this x. So -9, x plus 3. F to the x equal negative 9x. X. What about if I have x plus 3? So I'm going to put x plus 3 here. Now I just need to simplify it. Distribute, so it's going to be negative 9x. Negative 9 times 3 is going to be negative 27. So this is the first one. Negative 9x minus 27. The second one, B, we're going to do the opposite thing. We're going to do G composite with F to the X. So G is out, F to the X inside. G out, F to the X, I'm going to write down the whole F to the X fraction, which is negative 9x. This is going to be equal. Now I'm going to plug in instead of each X in F and G of X, I'm going to put negative 9x. And instead of each X in G function, I'm going to put negative 9x. So here's the G function. Instead of this X, I'm going to put negative 9x, and I'm going to keep the 3. So here's the X. Just simplify it, negative 9x plus a 3. That's it for this one. For the C, G composite with G itself. G composite with the G. With respect to the X. That means it's going to be G out and the same function inside. So G out, G of X, which is X plus a 3. Now I'm going to go to the same function, but instead of each X, I'm going to put X plus a 3. So here is the same function G, and instead of this X, here I'm going to put X plus a 3. Plus 3. Simplify this one, so it's going to be X plus 6. That's it for this one. So that's the whole thing for example 11. So we're going to put here negative 9x minus 27. The second one is going to be negative 9x plus a 3. And the third one is going to be x plus 6. That's it for this example. We're going to do the same thing with the 12. Let's go to 13. Let's do 13. Let's do 13. So for example 13, the first thing they ask you to find F composite with G to the X. That means it's going to be F is out, and G of X inside. So it's going to be, here is the F, G of X, which is X cubed plus 4. Now I'm going to plug in X cubed plus 4 in F function. Like instead of each X in F, instead of each X in F, I'm going to plug in X plus X cubed plus 4. That means this one is going to be equal. Here is the F function. And instead of each X here, I'm going to put X cubed plus 4. So X cubed plus 4. Sorry, minus 4. Yeah, plus 4 minus 4. Now we need to simplify it. So cubic root X cubed plus 4 minus 4 is going to be the cubic root of, this is 0, X cubed. The cubic root of X cubed is going to be just X. That's it for the first one. The second one, they ask you to find G composite with F to the X, which is going to be G is out and F to the X inside. G is out. Now f of x, here is f of x. This is f of a cubic root of x minus 4. Now, I'm going to go to the g function. Instead of each x in g function, I'm going to plug in this number. So here's the x in g function. I have to plug in the cubic root of x minus 4 cubed plus 4. Now I need to simplify this one. This cube cancel with the root. So it's going to be x minus 4 plus 4. Cancel these. The result is going to be x. That's it for this one. C is going to be G composite with G itself for x. It's going to be G out, G over the x inside. G is out. Now G over the x, here's G over the x, which is x cubed plus 4. Now I'm going to go again to the same function and plug in instead of each x, I'm going to plug in x cubed plus 4. So this one is going to be x cubed plus 4 cubed plus 4. You don't have to simplify it. Just keep it like this. This is going to be right, 100%. Let's check our solutions. The first one is going to be just x. The second one is going to be just x. The third one is going to be 2 parentheses, x cubed plus 4 and cubed outside. And this one is going to be plus 4. That's it for this example. The same thing with example 14. The same thing with example 16. No, example 15 is a little bit different. It's the same way, but they're going to ask you for the domain and the range. So let's work on this one. So example 15. Let's check how we're going to solve it. Again, they give you two functions. And they ask you f of x is cubic root of x minus 7. So f of x equal the cubic root of x minus 7. And g of x equal x cubed plus 1. The first thing they ask you, find f composite with the g. So this is A. They say f composite with the g to the x. So it's going to be f is out, g of x inside. F is out, here is g of x. G of x is the function x cubed plus 1. Now, next step, in f function, instead of each x, I'm going to plug in x cubed plus 1. So here is the f function. Here is the x. Instead of this x, I'm going to put x cubed plus 1 and minus 7. Let's see. I don't think so. We can simplify it. So we have to keep it like this, because you can simplify this one. Just keep it like this. For b, we need to find the opposite thing. We need to find G composite with F. G composite with F to the X, which is equal. G is out, F of X inside. Here's the G, F of X, which is the cubic root of X minus 7. Now, next step, in G function, and instead of each X, plug in the cubic root of X minus 7. So here's the G function. Here's the X. I'm going to plug in, instead of this X, cubic root of X minus 7 cubed plus 1. The root cancel with this exponent. So the left is X minus 7 plus 1. And it's going to be X minus 6. We're done from the first one and the second one. Now they ask you, what's the domain of F? Domain of F function equal. Here's F function. It's a cubic root. We already know that if you go back to the basic function, the cubic root of X is negative infinity to positive infinity. So the same thing here for this function is negative infinity to positive infinity, but it's shifted to the right. Shifted to the right. So the domain is negative infinity to positive infinity. Let's check next one, domain of G. The domain of G, here is the G function, x cubed. The basic function is x cubed. The domain for the basic function from negative infinity to positive infinity. You have to go back and check section, I think 2.3, and I remember the number of section, when we study the basic functions. And the domain and the range for this section is negative infinity to positive infinity, and is shifted up 1 unit. So the domain is still the same, negative infinity to positive infinity. The next one, the domain of F circle G. That's been the domain for this function of F composite with the G. And the last one, the domain of G composite with F. Let's check the domain for these two functions. That means we have to study the new functions. The new functions, which is this one, it's exactly the same. It's still the same. It's a cube. Cube root, negative infinity to positive infinity. X cubed, negative infinity to positive infinity. So the domain for this one is going to be the same. What about the domain for X? X is the identity function and shifted to the right 6 units. So the domain for this function as a basic function is negative infinity to positive infinity. That's it for this example. So we're just going to type here. This is first of all, I'm going to type the cubic root. That's very good. Let's say, I think we have to operation, but we're going to get more. Let's check how we're going to write down the cubic root. So to find the cubic root, because when you go to the operation, only the square root. To find the cubic root on the functions, here is the cubic root. Cubic root of, and here is going to be parentheses, and x cubed. I'll go back to operation. X cubed plus 1. And outside is still under the root minus 7. And for the next one is just x minus 6. For this one, there's going to be just negative infinity to positive infinity. So I have to do it all. Negative infinity to positive infinity. And the same thing here. It's going to be negative infinity to positive infinity. And the same thing here. Negative infinity to positive infinity. And the last one is negative infinity Let's check the answer. So we're gonna go to the next example, which is now they're gonna give you the opposite thing. Not example 16. You're gonna do this one, which is exactly the same way. Example 17. Let's check example 17, how it look like. Example 17, you're gonna do the opposite thing. So here's 17. We have here find two functions f and g such that f composites with the g of x equal h to the x. So I'm gonna write down this f composite with g to the x equal h to the x. And they give you h to the x equal 5x plus 4 squared. 5x plus 4 squared. They ask you to find f function and g function. That means we're going to do the reverse thing. We have the solution and we need to find f and g. So don't confuse yourself about this function. This just plug in this function here. That's mean f composite with the g to the x is going to be equal 5x plus 4 squared. This function is the inside. If I want to write down this using the rule, f composite with g to the x equal f out g of x inside. So I'm going to write down this here. F out g of x is the one inside. That's mean equal 5x plus 4 squared. So g of x is going to be everything inside. That's mean g of x is going to be as a function. G of x is going to be 5x plus 4. That's it. This is g of x. Now we need to find f of x. I'm going to just plug in, and instead of this one, a big x. So it's going to be x squared. This means f of x is going to be x squared. That's it. How are we going to check this is the right solution? You have to go back just to check. You're going to go back and use these two functions to find f composite with g to the x is going to be f, and here is g of x. So here is f, g of x is 5x plus 4. Then I'm going to plug in, and instead of each x in f, I'm going to plug in 5x plus 4. So it's going to be 5x plus 4 squared, which is exactly the same thing here. This is just to check, but the solution is going to be like this method. Let's do another example. Let's check our solution. That's mean they're telling you write down f of x first, which is x squared. Then I'm going to put comma and write down g of x, which is 5x plus 4. That's how we're going to type it. We're going to do the same thing with example 19, 18, 18. So the same thing, but now we have different fraction. So let's do, here is 18. So now example 18, they're telling you find two functions such that f of x, f composite with the g is going to be h to the x. And they're telling you h of x equal 3 minus x cubed. 3 minus x cubed. So that's mean you're going to plug in this one here. So f composite with the g to the x equal 3 minus x cubed. The same thing, I'm going to write down this because we already know f composite with the g to the x is equal f is out, g of x inside. That means this one is going to be f g of x equal 3 minus x cubed. So g of x equal anything inside. That means g of x is going to be equal 3 minus x. So f of x is going to be the outside, which is the cubed. So I'm going to put x cubed. Again, to check that, just have to do f composite with the g to the x, and your result is supposed to be equal to this one, 3 minus x cubed. This is for example 18. So I'm just going to type here g of x, first of all, f of x, which is x cubed. So x cubed, comma, g of x is going to be 3 minus x. Let's solve one more, and that's it. So let's check, let's solve 19. Example 19, we're going to do exactly the same thing. Find two functions. So 19, we have f composite with the g to the x equal h of x, and h of x equal cubic root of x squared minus 7, cubic root of x squared minus 7. That's mean f composite with the g is f composite with the g to the x equal the cubic root of x squared minus 7. That's mean in this case, this one is going to be f is out, g of x inside, which is equal the cubic root of x squared minus 7. Now g of x, everything inside. So g of x is going to be x squared minus 7. F of x is going to be the outside function. F of x is going to be the cubic root of x. Again, if you want to check, you have to find f circle g of x using these two functions, and the result is going to be the cubic root of x squared minus 7. This is only to check, but the solution is going to be these two functions, because that's what they ask you to find. So this one is going to be, I'm going to write down f of x first, which is the cubic root, not the square root. So I'm going to go to the function cubic root of x, and comma g of x is going to be x squared, squared minus 7. That's it for this one. And you're gonna do exactly the same thing with example 20.